Britain after the war was a time of austerity.
The tenements of Glasgow and Edinburgh are notorious. Half of them have only 1 or 2 rooms, and of all Scotland's houses, 2 in 5 have no baths.
The country needed electricity to rebuild the economy. The government believed atomic energy was the answer. But nuclear material was scarce and the atomic weapons program took priority. So Britain's scientists and engineers had to design a power station that was self-sustaining. Their solution was the fast breeder reactor. It promised a network of power stations that could produce more fuel than it consumed. A small amount of uranium in the core of the reactor would create enough heat to generate electricity and enough radiation to harvest plutonium. Special rods made from an otherwise useless type of uranium were installed around the core where they could absorb the radiation and turn some of this metal into plutonium. 30 tons of the metal was extracted from Britain's experimental fast reactor in the 1960s and sent to the Sellafield reprocessing plant in England, where the plutonium was recovered and used to make new fuel. The breakthrough created optimism about a new fleet of power stations running on their own fuel. But the discovery of oil and gas in the North Sea and new uranium deposits around the world weakened the economics of fast reactors, and by the 1980s the country decided the technology could wait. Today, Dounreay is being shut down and dismantled. But the plutonium these scientists and engineers bred here isn't being discarded. It can be used again to make electricity in the future. So an important part of the site closure is to get this material into a condition that will allow it to be returned to national stocks. This is the fuel made inside the experimental reactor's breeder zone. Solid pieces of uranium metal that now contain parts of plutonium. 11 tons of these metal bars were taken out the reactor when it closed down in 1977. They've been stored here for the last 20 years. Now, as the site closes down and the plant is demolished, these bars are being retrieved and made ready for their return to national stocks.
For the last 3 years approximately, we've been taking in 24 drums of breeder material. And each drum contains 5 cans, and each can has approximately 12 irradiated fuel rods. Our job then is to declad these fuel rods one at a time. And how we do that is we take it into our wet cell and we put it in our declad machine that was specially built for the job. It's a hydraulically driven machine. Basically, we have 2 cutting blades that run down either side of the rod, and we just gently increase the pressure bit by bit, and eventually the cladding should come apart and separate. Once that happens, sometimes we have to do 2 cuts, sometimes we have to do 4 cuts. We found that we've had, I think it's depending where the rods have been in the reactor, we've found some are a lot stronger and they've taken maybe 20 cuts sometimes. We've found rods of different types. They've been straight, they've been bent, some have reacted in storage, and they've had swollen rods, some like bananas. So we've had various problems and difficulties, but we've overcome them all. Once we declad the rods, separate up the fuel from the cladding, we will then send that back to storage. We will put each fuel slug in a designated can for accountancy purposes, and we will then repackage it with the declad material on the outside. It will later go to waste after it goes to storage. Once it's in storage, eventually we'll come back here, 1 drum at a time, and what we're going to do then is inspect the fuel. We've got a certain criteria it's got to make. We're going to clean it and ensure there's no impurities on it, and then we're going to put it into recant tubes. And to do that, we're going to make up a no-go gauge, so the criteria is met, the tolerances that are required are met, and we'll put them in the recant tubes inside the cell. And we're making up special equipment at the moment that will then close these recant tubes, and we will do that one at a time. And then we've got a special converted drum from DFR that's going to come over, and we're going to put these recant tubes into the drum, and send over to DFR.
There's another 33 tonnes of this metal still inside the reactor. Special tools are being installed to reach down into the reactor and remove the bars of metal. Each rod will be lifted out over the next few years and packaged up in the same way. Their removal is an important part of the work to dismantle the reactor and demolish the entire site. The Nuclear Decommissioning Authority, which owns this metal, will decide during 2011 what happens to it after that. One option is to recover the plutonium and use it to make new electricity. So the metal is being packaged up in a way that will allow it to be recycled. The material that inspired a whole nation 60 years ago may yet bring the power of electricity to a new generation.